Okay, welcome everyone. Thanks for coming to our .NET Engineering Forum today. This virtual meeting, we did this a month or so ago and it worked out pretty well. So we're going to try it again. Today we have Chris Wiederspan from the Microsoft organization in, I think he's in Colorado. And he'll be talking to us today about Dapper, managing microservices. He will talk some about Docker and Kubernetes and all kinds of cool stuff that we need to know about. We appreciate Chris being here and being able to join our virtual meeting.
All right, so I'm going to go ahead and share my screen here. Again, this is Chris Wiederspan. I work for Microsoft, repeating everything that Jim said. Specifically today here to talk about Dapper. I do have a couple slides, the idea being just to walk through what it is, why we need it, where it fills a gap, and kind of go from there. So hopefully that works for everybody. This isn't necessarily part of the slide, and apologies, I'm going to just use the PowerPoint view because I want to kind of cherry pick a couple slides and jump through here versus going through all of them. This slide here is really not part of the deck per se. It's just one of those slides I always like to show people. This is one of those things that when we see customers that are moving very fast, they're able to react to, for example, COVID-19 and create systems and applications that they need to get by. This is some of the traits that we notice about them. So we kind of notice there's the intersection of containers, DevOps, microservices, and Kubernetes. And Dapper kind of ties, is one of the things that starts to tie all these together. So let's talk about, kind of some of the problems or some of the things that you may be going through within your organization and what lots of other people are going through. It's just being an enterprise developer, being asked to do resilient, scalable microservices. You're likely, if you're kind of using a microservice approach, and I know you guys are at the church there, you've got multiple languages, Java, .NET, Python, you name it. Those can all go into building a microservice infrastructure. So, that's one of the things that we encounter often. And then, from a developer standpoint, you want to be building apps and not infrastructure. And frankly, that should trickle up the organization as well. We're kind of getting past the point where companies are really focused on IaaS in the cloud, infrastructure as a service, and really they're starting to focus on the higher level cloud services, things like the PaaS platform and some of these managed services like Kubernetes, which we'll talk a little bit about here today. So what are the impediments there? What's keeping us from that? Limited tooling and programming models, things that are agnostic to language. It's hard to build a framework that fits all different programming models just because most open source organizations or people that are building those things, they can't really keep up with doing that across multiple programming languages. So lots of different things that they'll run into there, but needless to say, it's been a hard thing to tackle over time. Here's what Dapper is, Dapper's goals, the idea that we can build in best practices using building blocks. And we'll kind of talk about what building blocks are out there and what that means. Consistency and portability, right? Being able to take this across languages, across runtimes, across different platforms, and expect it to work the same the whole time. Extensible and pluggable components. I mean, Dapper is an open source project. It was kind of fostered by Microsoft and started out as some Microsoft efforts, but it's fully open source. It's built in the public realm, so anybody can participate there. You can go check out all the source code. You can do pull requests against it, all the stuff you would expect from a typical open source project. And I won't go through all these, but you get the idea there. The idea that Dapper is meant to solve a lot of these problems that that enterprise developers, especially in a microservice world, are running into. So what is Dapper? I'm just going to read this. Dapper is a portable, event-driven runtime that makes it easy for developers to build resilient microservice applications that run on the cloud and edge, right? So given what we talked about in the first couple slides, that probably aligns with that pretty well. Hopefully that makes sense. So let's really kind of just get into it and talk about what it really is, right? So Dapper is it's a sidecar-based platform or framework, depends on your definition of those things, but especially if you come from Kubernetes, you'll be familiar with this idea of a sidecar. And it's when you're talking containers and talking Kubernetes, it's the idea that on one hand, I have the code in my application that I build, but on the other hand, I may want to bolt something onto the outside of it that runs in a sidecar, which technically just means it's in a different container, and those two containers can talk to each other. So if you're coming from the Docker world, hopefully that makes a little bit of sense. And if not, fire some comments in the Q&A and we'll go try and clarify that. But with the sidecar model, I only worry about my code, my application, and because this stuff runs on this sidecar that gets attached, I don't even have to take any dependencies. So inside of my C# code or my .NET code, I don't have to go loop in an SDK or bring in some code that's going to do things. I don't even have to do anything. So we'll see some examples of that as we kind of get through here. Technically speaking, from the Kubernetes or from the Dapper standpoint, the solutions that it's providing, these are those building blocks I mentioned earlier, service to service invocation. So if I'm writing microservice, ideally I'm not doing, I call it the chain of death, right? I'm not having service A call service B and service B call service C. I really want service A to communicate with service B via some asynchronous mechanism. Usually that's pub sub. So you see pub sub here, but if I do need to do direct service invocation from service A to service B, Dapper provides a mechanism for that. If I need to save state, so if I'm saving data to Cosmos DB or a Redis cache or a lot of different options, I can do that as well. So Dapper provides me a mechanism for doing that. I already mentioned pub sub, so if you're coming from anything from Kafka to Service Bus to Event Grid to you name it, right? I mean, any kind of pub sub topology, I can layer on Dapper on top of that. Resource bindings and triggers, if I want to take a serverless based approach, if you're familiar with something like Azure Functions, I can do triggers and bindings to kind of declare and configure what's going to fire my microservice, right? And then on the output, I can then, for example, write data to a database by using an output binding. So it does some of that. The actor model, if you're familiar with the actor model, that is a very popular pattern within microservices. It started way back when, and it's big in gaming. So there's a lot of game developers that have kind of perfected the actor model, but turns out it does great for business as well. And the idea being that an actor is simply a stateful representation of some entity. That could be a person and the records associated with them. It could be, in a game, it could be a rock, right? So lots of different options there. And then we get into more of the operational side of what Dapper gives us. So observability, secrets, extensibility, right? I mean, those are the ability to not only use Dapper to augment the code that I'm deploying and simplify the code that I'm building, but then give me the operational aspects that I need to do things like distributed tracing. So when I do have a problem or I need to view an application model, I can do that. Secrets as well, right? So if I'm using Key Vault in Azure or HashiCorp Vault, again, those have all been abstracted for me through Dapper, and I'll show you what that means when I talk about abstraction. So Everyone good? Everyone following there? Same thing down here. I just want to point out that, one of the things Dapper does, because it runs in this sidecar model, is that it works with any programming language. It has no bearing on your code, and likewise, your code has no bearing on it. So the way that it runs in the sidecar mechanism is very friendly to me as a developer, because I don't have to really change a whole lot with what I'm doing there. So these are, and I promise I'm not going to slide you to death here. This is kind of represents a lot of those different kinds of communications that I mentioned before. So, the way this works and kind of the drawing here is that if I've written service A and maybe my buddies next door have written service B, I may need to I need to make a call from service A to service B. So the way that works is these squares here are kind of representative of the containers and thus the sidecar here. So what happens is when I spin up my application, this Dapper sidecar automatically gets spun up and kind of paired with my service. And then as my network traffic goes in and out of my application, it actually goes through this Dapper sidecar, much like a proxy would. And so what happens is Dapper is able to then intercept all those network calls and then decide to reroute them effectively. So in this case, when I call service B here, it's actually Dapper intercepting that, sending it over to this application's Dapper sidecar, which then reverses that process and pushes it into code B. So you can see there that, I get a slightly simplified way of inter-service communication. So that's kind of that service invocation model. If I follow that through a little bit, let's say state, right? So in this case, Dapper knows how to talk to Cosmos DB, or it knows how to talk to DynamoDB, right? Somebody has written that adapter or that extension method that knows how to talk to this. The point is that in service A, I don't really need to know how to talk to these individual things. I simply need to know the convention to use to talk to Dapper, and then Dapper does all the heavy lifting to wire up the SDK for Cosmos DB, for example. So again, in that scenario, my code that I have to worry about gets much simpler because all the detail there gets buried inside of that external implementation. Similar pub sub subscribe, RabbitMQ, Redis, Service Bus. I mean, you see all the main players there. Again, me making a publishing a message from my code gets very simple because Dapper then intercepts that and then knows how to interface with Service Bus, for example. So you kind of get the idea across the board how that's going to work. Let's kind of keep going and we'll get to some examples there. This is a good illustration of that. This is right here where you can see this local host. You'll notice port 3500. So when this guy talks to Dapper, he's actually doing it through port 3500 or a similar port number, as you'll see when we get into the demo. And so all he has to do is say, hey, I want to go localhost 3500. This is version 1 of Dapper, so it's got versioning built in. And then the action is I want to invoke, and then cart here is the name of the service that I'm going to invoke it on. And then I method, that's a constant, right? So it's saying go invoke this method, and the name of the method is checkout. And so you can see that cart B over here is essentially exposing this checkout method, but because I've named my my application and because it exposes this method, the two Dappers that kind of sit in that middleware layer, if you will, they know how to talk to each other and intercept that, and they're proxying that traffic on my behalf. So again, some of this will make a little more sense when we get to the application. Similarly, state management, if I want to save state, I really just have to say v1 state. I name my store name, we'll show you what that means. And then I'm posting or getting, in this case, a planet, right? So when I hit that URL from this service, Dapper is going to intercept that. It's going to go talk to Cosmos DB. It's going to package up that data, and it's going to give it back to me. And so my code looks essentially like a one-liner to get that data, whereas if I were using, for example, the Cosmos DB SDK, that's probably 10 lines of code. So,
hey, Chris.
Yes, sir.
There's a question that says, I noticed on your slide AWS DynamoDB, does Dapper have some cross-cloud traversal capabilities?
Yeah, that's a good question. So, and I kind of glossed over it. Currently today, Dapper is meant, or it's currently implemented to run on a Kubernetes cluster. And I know y'all aren't using Kubernetes a whole lot out there, but maybe that changes. And also Dapper as it goes, so Dapper currently is in preview. It's on version 0.10 right now. So it's been there a while, almost a year now in the preview stage. So it's getting closer to coming out in GA. But the point being, as it matures, the goal there is to take it out of a Kubernetes exclusive runtime and make it so you can run it in, for say, Azure Functions or AWS Lambda or Azure Container instances, right? And the point I'm driving at there is that currently you could take Dapper and you could run it right now today in AWS on EKS, right? So from that standpoint, it's completely cloud agnostic. The thing you can't do right now today is have some of your microservices sitting in, for example, Azure's Kubernetes AKS, and then some of your other services sitting in AWS on EKS, right? There's no line of sight there for the Dapper sidecars to be able to talk back and forth to each other. So at this point, it is confined to all running within one cluster, which, I mean, I'll be the first one to admit that that's a little bit of a limitation that I want to see go away. Good. Yeah, Rich, hit back on that Q&A if you have more questions there. So again, hopefully the state management side of this makes sense. I'm just pushing and getting, or posting and getting data to an endpoint, and Dapper's doing the magic under the covers to actually go hit the underlying service. One more here, pub sub. I mean, not a whole lot different here other than the structure of the URL that I'm using changes a little bit. So you notice publish here, notice state here, and then notice invoke here. So hopefully that starts to give you an idea of what some of this is going to look like when we actually get into the nuts and bolts here. So I think that's about it for slides. I may come back to these if we have time and get a couple more. But let's dive into the code here, and hopefully everybody can see my screen okay. Is that font big enough? I'm going to see if I can make it a little bit bigger. So I'm going to go ahead and if you've seen any of the Dapper stuff, odds are you've seen this demo before. This is a distributed calculator. Bring my other screen over. It looks something like this, just so you know what we're looking at when we get into the code. 8 times 9 equals 72. Not a whole lot of rocket science there. It's not the world's most sophisticated calculator. But what it's doing from a higher level architectural standpoint is each of the 4 orange buttons here, divide, times, minus, and or subtract and add, each one of those is a separate microservice. So what we're kind of driving at here is we have this React app that provides the UI. The React app also has a backend API. And so when React talks to its backend API, that backend API is wired up to Dapper. And then I have 4 different microservices that are also wired up to Dapper. And so the 5 of them together kind of form this microservice ecosystem that they all know how to talk to each other through the Dapper mechanism. And therefore, I can make my code a little bit cleaner. So the, you know, at a high level, a couple things I'm going to point out here is, sorry, I'm jumping around a little bit. So I've put all of this in a GitHub repo. So if you want to go check it out and look at it, I also have the slides printed out as a PDF. But this URL here gets you to this GitHub repo. So if nothing else, just grab a screenshot of that, learn Dapper, or maybe Tony can type it into the window. But that'll get you here and you can come find all the code. The overall structure of this is, if you remember, or if anyone was there last time I came out there, we did a lot of talking about dev containers. So I'm using a dev container here. The reason I'm doing that is it gives me the ability to wire up all of my Dapper stuff without actually installing any of that on my bare metal laptop. So that's not really the conversation today, but I do want to point out that that's a cool feature that I'm using there. I'm using VS Code, so I got the junk in there. And then we've got the source code, and I'll drill into this a little bit more, but you can kind of see at a high level, I've got my React calculator. No surprise there. That's just a couple React files and then the actual client stuff. You know, we're not really here to talk about React today, so I'm not going to spend a whole lot of time on that. You know, the way the calculator works is we actually implement each of those 4 operational microservices as different languages. And the idea being that it is agnostic and kind of showing how all these things can talk to each other. So there is one in C#. That's the one we're going to kind of drill into here in just a second. But you can see Go, you can see a Node endpoint, and Python. I knew I was missing one. And then this is the, you know, I forked this from a different resource, which I want to show you. So this is the, on GitHub, this is kind of the home page, if you will, for Dapper. And you'll notice there's a repo for Dapper itself. So you can kind of come in there and that's all the source code that makes up Dapper, a bunch of the images and stuff we talked about. So you can come check that out. The docs page, lots of good stuff in there. You'll notice there's a quick start and a samples, 2 separate repositories. Go check those out. That's where you can find a bunch of good samples. I actually took this distributed calculator, so this probably looks familiar. I've made a couple little tweaks in there, but nothing material at this point. So if you want to start from scratch, you can always come in there and grab that. But there's also some samples, and if you read the docs, there's some talk about why there's a quick start folder and a samples folder, and they're kind of in the process of juggling some stuff around. So just beware of that. So that's kind of the Dapper ecosystem and where you can go get all of this. But needless to say, I'm guilty of forking that repo and grabbing their code, and that's most of the demo that I'm going to show you today. You know, I've tried to paint, part of what I did is I tried to curate some of the steps that it took to get started. So you'll see, that's interesting. Yeah, you'll see that I've got a bunch of steps here that walk through setting up all the different components. Most notably, well, sorry, one thing I want to show you here. This is what it's like to, let's find the C# one. This is what it's like to set up Dapper or to run Dapper with your application. So I'll show you this here in a second live, but you'll notice that this is, make that a little bigger. Part of Dapper is a CLI, so there's a CLI and some binaries that get installed when I kind of provision it on my device. And I mentioned Kubernetes. I probably should mention too that there is the local development environment that I can use. So I can do all this on my own laptop without having Kubernetes installed anywhere. So when it comes to building these things and kind of going through the motions and getting everything up and running, there is a good story for that. So everything I'm going to show you today is all local. Anyway, so I can take the Dapper CLI, I tell it to run, I name this app. So the app ID subtract app. If you remember back to our slides when I said that, we do our service invocation. Where was that slide? And I had to name that, in this case, cart. So this cart is matching whatever I have here, in my case, subtract out, right? So that's
one of the questions was, if you only want to see the .NET implementation, you'd only have to look at the subtraction code. Is that correct?
Correct. Yep. And there's a lot of other samples and demos out there that are purely .NET. So don't feel like you gotta zero in on the distributed calculator here. Right. So when I run this, I'm naming it. I'm giving it some ports. This is the port that my .NET app actually responds to. It's just typical .NET. So I told it 7000. This is my Dapper port. I mentioned earlier that kind of the default port is 3500. In my case, I increment up. You'll see 3503, 3504. Just because I'm running multiple instances of Dapper, they can't share ports. So each one gets its own port, and then they talk through their associated ports. And then the last part of this command is just me telling it what to actually run. So in this case, I'm just using the .NET CLI and telling it to run my subtract DLL that I compiled up here. So again, I'll show you this in action, but I just kind of want to dissect this while it's on the screen and show you where we're going to go from there. So back in my code, let's go look at what's actually in this C# code. The short answer is not much, and that's kind of the point, right? So I've got my typical program. That should look boilerplate. I haven't touched that. I've then got startup. I haven't touched that other than just rearranging some stuff. So you'll notice no mention of Dapper. If I look at, where's my CS proj file, no mention of Dapper or any SDK, so I didn't have to bring anything in. And again, point being, there's nothing going on there other than the out-of-the-box project new. So then when we get up here, I do have a model. I mean, nothing other than just a model. And then we have our subtract controller. So this is kind of where the magic is for the application, the .NET app. No different than an API controller that I would write as normal. And here's my method, right? So it's going to take an HTTP post. It's just called subtract. It's taking that model I just showed you as the input. And aside from the console, right, it's just one line of code. And that line of code is pretty basic. It's just parsing out some strings and then doing an actual minus operation on that. So no real brain damage there. So what can we do with this? And I probably could have come up with a better demo, or I'll give you a better demo at some point. But the point is that from here there is no Dapper, and if I want to come run this now, I've already done a couple of these steps to build and whatnot, but this is me just running that same command I showed you. I think I've got a little extra junk here. But when I run that, you can see what's happening is that Dapper is spinning up the executable. It's latching on to my executable, and now it's teed up so that it can intercept anything that's going to that port or to that endpoint, as it were. So some of the things I can do, and I got to get my cheat sheet here, is sorry, I knew that wasn't the right thing I was looking at. I said earlier I curated some of this. This is actually what I curated. So these are these match better to what the commands I'm actually running are. And you can see this is our subtract application. We just went through all this, we compiled, so there's nothing there. What I do want to bring out is copy this line. And you can see that now I'm gonna, and this is just a utility. I mean, this isn't necessarily anything to do with my application. I can use Dapper in the CLI to essentially trigger that method. So I'm going to pass in, subtract 10 minus 7. I should see 3 back there. If I grab that, which I think I already did, come back over here, just create a new one, and I paste that in there, you can see I get my 3 back. So what does this prove? Again, not a whole lot, other than Dapper is I'm proving that Dapper knows how to talk to my application, and that if I pass the right JSON into it in the form of that model, that it's going to execute that code and give me the result back. So we're just kind of proving that out piece by piece. Now that I'm running, I just kind of closed the loop on this. If I come in here and say 9 minus 8, 1, no rocket science there. But what I can also do, and let me see if I can do this, you get where I'm going with this, right? I can start getting telemetry out of here. I can say 6, let's try that again. 6 minus 3, for example. And when I run that, Dapper's intercepting that call, and it's showing me the output, just some console logging there. So that console logging was that one line of code that I said we had in there. All right. So again, I'm basically, from the microservice standpoint, I'm simply latching on to Dapper or vice versa to enable that microservice. If we really want to see the cool part of this, we have to go to the React app. And so within the React app, now I can see how it simplifies me calling into that service. So again, I'm not necessarily a React guy, but I know enough to kind of follow through this. And essentially all I'm doing is setting up endpoints. So this is my middle tier, if you will. This is the server.js that's sitting here in Node running as the backend for my React app. And again, it's also wired up to Dapper. So I have one of these things here that's running the CLI, running the client application. And the beauty is that inside of my method here, when my React app is calling calculate subtract, all it really has to do is it just gets this Dapper URL from up here. So I've got a variable, which is my Dapper port 3500. In this case, it really is 3500 because it's the one that I gave the default port to. So it comes in and it constructs this URL, this Dapper URL, sticks the port in. It does the /invoke, like we talked about back on the slides. And then when it actually executes, it's just tacking on the subtract app. So /subtract app, that matches the parameter that we passed in when we started up the microservice. Hopefully I'm not confusing everybody too thoroughly. Method, again, is just a constant. That's just saying I want to invoke a method. And the name of the method is subtract, which matches my method call that I plumbed up over here on the controller, right? And so when it hits that, again, you can imagine all it's doing is it's doing a post against this URL using this payload, which then gets into Dapper. Dapper talks to Dapper for the other sidecar, and that passes into my sidecar or into my API application and then back through the chain. So hopefully that makes a little bit of sense there. And
so again, there was a question in the chat that says you would call. He says port 7000, but I think it's port 3500 or the Dapper port to make the post API call, and not directly to your application. Yep. Isn't that correct? It's going to proxy that for you.
It does proxy that. The inner loop development, right? Like if I want to build this thing and test it without using Dapper at all, I mean, I can just F5 this, right? And it's going to spin up my C# app natively, meaning no Dapper, nothing. And so in theory, it's running there. Ignore that. That's just a certificate thing. And then, for example, if I want to bring over Postman, you can tell I was prepared for this, luckily. So this is, I'm actually mapping this through port 7700, but I can put in my subtract. This is my payload. I can send that, and it's just hitting my raw API at that point. So I completely bypassed Dapper. And again, that may not be the direct answer to the question, but the point is that I've got options there. I can go ahead and just build my own services and debug them just like they were native C# web apps. But when I blend in Dapper into there, then, for example, let's see if we can do this on the fly. I'm going to post to do that, but instead I'm going to do invoke subtract app. I think I need a method, right? And I grab my payload here again. Body. See if that works. And I think I probably need to go. Anyone remember what that was? If I have a 4, oh, yeah, I mean that, oh, I know what I got. Sorry, always dangerous trying to do stuff on the fly. And I don't think I'm really proving anything here.
Yeah.
Other than I've got different ways I can call these things now. I can call it natively. I can call it through the Dapper layer, if you will.
So I guess the question then becomes, obviously we could have the React app call the .NET app directly, and it could make invocations to each of those underlying apps, the Python app and the Node app, each of those directly. The benefit, I guess, to using Dapper is that it's kind of the glue that sticks everything together and simplifies the call structure. That it's a little different. Like your invocation to the backend would be, subtract app, whatever the API call is, but your invocation to Dapper is always a standard pattern, like invoke the name of the app /method / the name of the method. And I guess that if you were just orchestrating a bunch of microservices for REST calls alone, maybe it feels like a little overkill, but I guess it starts getting a lot more interesting when you blend in things like a service bus and other triggers and stuff like that. That's where it probably gets a lot more interesting.
Yeah, absolutely. And you know, some of the things I can do is I can toggle between HTTP and REST and gRPC. So now that I'm all in the same cluster, it makes a lot more sense to use gRPC for my inter-process communication. So Dapper gives me that. You're exactly right. Like, this isn't a great use case to showcase all the use cases or all the benefits of Dapper. You know, I think probably and I wasn't really going to dive into this just because this is in the React app, but one of the things the calculator is doing is it's storing the state of your equation, I guess, in a state store. In this case, the state store, and I probably want to mention this anyway, so I have this components folder. This is a big part of how Dapper works. There's a components folder out there, and you'll see a couple YAML files, including, for example, this state store. And what I've done here is I've defined that the name state store is bound to, in this case, state.redis. So that's a well-known string that says, I want to use the Redis implementation. And then I have to give it things like an address, and in this case, an empty password. We're not using state, actor state, but I've initialized it for that. So everything here becomes configuration. And the beauty is that that configuration could be controlled by, for example, an SRE team or an infrastructure team that was running my cluster. Me as a developer, I wouldn't necessarily have to know that. So if my, you know, on cluster A, we wanted to use Redis, and on cluster B, we wanted to use Cosmos DB, maybe one's non-prod and one's prod, that can all be configured at a cluster level without me as the developer having to know anything about it. So long story short, keep an eye on that components folder. That's part of the magic of Dapper, or maybe it's the unmagic. That's part of the fuel of what drives Dapper. But coming back to here, you know, all I need to do to store state is call this URL and then pass in my data. So again, imagine where we're doing that with one line of code here. If I were using Cosmos DB and I took a dependency on Cosmos DB SDK, again, this would be 10 to 12 lines of code just to wire up my connection string, and open the connection, find the right database in there, post the data, you know, you get the idea, right? So it does abstract that. And so back to the question, you know, again, this may not be the best illustration of all the features, but when you start piling them on each other, and, you know, certainly I've been there before, if you live in a microservice world and you are really building a lot of microservices, this is where things get ugly, right? When I have to keep track of service discovery myself, or I have to build out a service discovery mechanism. So Dapper brings that to me and makes it real easy. So yeah, again, probably not the greatest demo for showcasing all the features, but hopefully it's enough to just show you the mechanics of kind of how it's working.
So it seems like it allows you to kind of, instead of taking hard dependencies, keep everything loosely coupled so that if you want to swap those out, as long as you maintain the contract, the application doesn't really care. If you decided to say, you know what, that node implementation for, what is it, addition is horrific because JavaScript can't handle decimals, so let's rewrite that part in C#. You could do that and everything would be happy and
right.
Work great.
Yeah. Yeah, and there are other tools out there that, you know, for things like that specific case, I could work around. service discovery, inside of Kubernetes and even outside of Kubernetes, that notion of service discovery is becoming pretty prevalent. So there are tools that'll do that. There's tools that are that try and abstract your storage layers. Entity Framework is one of them, right? So there's all these tools out there. I think what Dapper is really trying to do is kind of coalesce that all into something that developers can really get behind when it comes to building these microservices. And it's an opt-in component, right? So I'm using it for service invocation here. We've got the one piece that does state for storing the calculator state, but I don't have to use any one specific. I can pick and choose if I had a better state management solution, or if I was using some database that didn't have an adapter there within Dapper. Nothing says I can't just go take that dependency on that database's SDK and use that. So it's a really pick and choose your own adventure there.
Okay, cool, thanks. I'll let you keep going.
Yeah.
Good questions.
Yeah, keep the questions coming, because getting close to the end here. I do want to show you a couple more things. Not that this is really too much about it. So this is, if you know what Flux is a GitOps operator for Kubernetes. So this is what I'm using to install this app. And you'll notice it's really just a bunch of YAML files here. Point being, and I'm using the off-the-shelf images for the calculator that are out there, so you don't have to actually build your own images. But piecing together what this looks like to install on a cluster, and then I can do things like come over here and do let's do all. Right, so I'm just doing a kube control on my Kubernetes cluster. I want to see all the pods and services and stuff, and I've got Dapper installed in the Dapper-system namespace. So this is what it looks like when Dapper is actually installed, for example, on a cluster. It's got a dashboarding component. It's got the operator placement. This is the part that essentially auto injects those sidecars. Sentry is some of the logging and whatnot. Sorry, actually, this is the sidecar injector. This is the service discovery mechanism. So I've got a bunch of pods. I've got services. I'm not really tending to blow your mind with a bunch of Kubernetes stuff, but when I think it's sample.
There's another question in here. It says, user says, I'm sorry if this question has already been asked, but would you say that Dapper could be used as a replacement for Entity Framework? Would you think these are different tools, or could Dapper replace Entity Framework?
I think, most of the Dapper implementations of the data are based on NoSQL underlying data stores. So you've got Cosmos DB, DynamoDB. They're not necessarily geared towards relational databases. So, specifically with SQL Server, I would probably just stick with Entity Framework, especially within a .NET application. I don't know if there's plans to bring a SQL adapter to Dapper for SQL Server, so I'd have to check on that. So my earlier analogy with Entity Framework wasn't really a good one. Probably Cosmos DB is more appropriate. Hopefully that answers that question. And again, this is still early days for Dapper. There's currently no real query mechanism for querying the state store other than like an ID, right? So I don't really get the ability to say, hey, return me all of my items that are blue. So I do know that if you There's I think it's every 3 weeks, there's a community call for Dapper. It's all open. You can go watch it live or record it. They're on YouTube. They're very informative. You'll see what they're working on for the future implementations. They talked this week, there was one this week, they talked about being able to return multiple items from a state collection. So again, point being, it's still very rudimentary, and it's based on things like NoSQL and name value stores where the value is the JSON or the NoSQL chunk. So keep that in mind. Still have a little ways to go on, really making the state store something that provides things like query capabilities.
Yeah, so the follow-up comment there was, so for RDBMS, relational databases like SQL use Entity Framework, document databases, NoSQL use Dapper, and I assume the answer there is it depends, right? If the implementation that you need is pretty basic and simple, you'd use Dapper. If you need something a little more complex where there's business rules involved, then you would probably have some sort of a microservice that would interface directly with like Cosmos DB and manage those rules in between. Is that fair?
Yeah, it is. And there's also what I would kind of call a hybrid approach where, again, if you have microservices, one of the tenets of the microservices is that you're going to have one service that generally is responsible for writing the data, and it owns its own database for storing that data. And then there are other services that may either need access to that data, or they'll use some sort of pub sub mechanism to kind of keep their own version of the data. And it's that keeping your own version of the data where I think that the state store really comes into play, right? So usually that's a much simpler operation for those auxiliary microservices that just need access to the data than it is the core microservice that owns that data, where it may have a lot more, it may need a much deeper integration with that data store. So again, point being that maybe in one of my microservices that owns the data, I'd go ahead and use Cosmos full SDK, but all of my other services that don't need all the bells and whistles of the SDK, they could just lean on the Dapper implementation to give me the basic data by ID, for example.
So Rich had a follow-up on that. He says, you mentioned a goal of the project is to take Dapper out of the K8s or the Kubernetes runtime. Is there a roadmap or timetable for when that work might be done, or do you know, I guess?
I don't know for sure. There's definitely a lot of talk. I think things like Azure Functions are are being actively worked on right now. So I would expect that that'll be one of the first places you'll see it kind of emanate out of Kubernetes. The question is, how do you? So the way Dapper works under the covers is it uses multicast DNS or IP address. I mean, that's above my pay grade on what that all means. But it essentially means that currently the mechanism for service discovery and how they talk means they all have to have line of sight within a fairly closed environment. When you take that out into the Azure function world, you're talking about putting different things in conceivably different parts of the world that still need to talk and get that same type of functionality. So early on, they recognized that, and they made that service discovery mechanism pluggable. And so there may already be implementations out there. I haven't never seen anything that's kind of got the official Dapper stamp of approval. But to make all that work, somebody's got to put in the time and energy to make that service discovery mechanism in a way that doesn't require that multicast IP stuff to do line of sight service discovery and keeping track of that. So, maybe what you'll see at some point is some sort of container that you spin up in Azure Functions that serves as kind of a central hub, and then all your other Azure Functions kind of, when you declare, so through like that components folder, you would put a YAML file in there that says, hey, here's my service discovery hub, and any service that, any Azure function that can talk to that using some sort of key, then they're all within the same network. So I think that's what you're going to see over time. I would also venture a guess that the announcements a couple of weeks ago about Microsoft Service Mesh, the open service mesh, may have something to do with that, because that, you know, Dapper and service meshes start to go hand in hand on some things.
So another question that came in was, can you wire Dapper to web services hosted on other infrastructures? For example, let's say we have Docker image running Dapper. Can it orchestrate services hosted on other platforms such as Cloud Foundry, for instance?
Yeah, I don't think you can yet, but I think that is an intended use case at some point.
Okay. So I know we're running out of time here. We don't want to keep you all day, but did you have anything else you wanted to show just to close out?
I don't. Again, if you want to come check out the repo, and if you have follow-up questions, I surely, it's hard to do it all justice in an hour, but here's that URL you can go visit to kind of get the sample and the, you know, slides. My contact info is on there, so please reach out. Okay.
Well, thanks, Chris. I think this has been really interesting and informative. It's really cool to see where things are headed, and appreciate your time and spending some time with us today.
Yeah, you got it. And my last parting note, just because I'm a true believer of this, is go check out the dev container stuff. I know I preach about that every time, but I mean, that's the type of thing that really can make your lives as a developer a lot easier. So check that out as well. And thanks, Tony, Jim, and everybody else that joined. Appreciate it.
Thanks, Chris.
Okay, talk soon. Bye.
We'll see you. Bye-bye. Thanks, everybody.